Hello Kurt. Using your basic layout idea, I labeled the switches SP1, 2 and 3. I checked that 0 is straight, 1 is the turn to the right and 2 is the left turn. Identical for all three switches. I set up 7 trains and labeled them for 7 destinations. And I've added labels to the track ends to remind myself what's where. Now, the first thing I do is I build a list of switches that need to be set for this particular train number 4. Okay. The list will contain tables. And you can see now what the difference between the two is. The list has numbered entries, whereas the table has entries which get a name. So I want to store an object, my switch point, the actual track object. And that's SP1 in this case. And I want to store a number, the switch point setting, which is 0 in this case. And I need this twice more for the switch points 2 and 3, each containing 2 items. I have a list of 3 tables, each consisting of 2 items, the switch point and the setting. So I copy this and paste it twice. Now I edit the entry number 2, and all I need to change now is the switch point, the object. This is now for switch point number 2, and the last one is for switch point number 3. And because I selected the straight route first, the route number 4, the center route, I could leave all settings at 0. This is now a list of all settings that need to be done to guide train number 4 into track number 4. The list is almost identical for all trains. So for all of these, I now define one simple event. The event is that the track contact is triggered, and upon entering it, we want to do an iteration. We want to repeat as long as we have items in a certain list. The list is stored inside the triggering vehicle under the name route. And you know, those are the items 1, 2 and 3, and each item is now one, well, it says iter here for iteration. You could say it's one item or one element from the list, or why not say one switch. It's the definition for one of the switches. Now with this set, I can define the action that I want to perform. I want to set a switch. And the switch now is inside that one item I picked from my list. Inside that, I have a table. So I check my item from the iteration and look inside the table. From this switch, I look for an entry called switch point. That's the object I want to affect. And the position I want this to set the switch to is stored in the same manner. It's in a table. The table can be found in my iteration, and the name is setting. So from my list, I pick 1, 2 and 3, and each one gives me a small table with 2 entries, and that is my combination of a switch and the switch setting. Yeah, once again, I have a root here which has 3 items in it. And my iteration reads every one of the 3 entries, finds inside each one a switch and a setting, and uses those for the command set switch. Yeah? After number 1 comes number 2. In there it finds switch point 2 and the setting, and then number 3 is treated the same way. That's what this loop is for. And when I now copy the table to this train that's supposed to go to track number 3, I have the same setting everywhere, and all I need to do is change switch point 3 to setting 1 for a right turn. That makes things really easy. I copy the entire root setting, that one. I select the train that's supposed to go to destination number 3, and I paste my route. And all I need to do now is change my switch point number 3 setting to 1. And the same goes for all the other trains. Here's my train number 5. I can use the same list again. The only alteration is switch 3 must be set to setting 2 for a left turn. Train 1 only needs one switch set, the first one, because it turns out at the first switch and the other 2 don't affect its path at all. Switch 1 is set to 1, and that's all we need in this train. Train with destination 2 requires the first 2 switches. Switch 1 set to 0, and switch 2 set to 1, but switch number 3 wasn't needed anymore. Which means we never affect a switch that doesn't apply, that doesn't concern us. We only affect those that really are of any interest. Okay, time to put this to the test. Let's put them on the track in any order. Well, that one's looking good. What about the next? Hooray! Going to track 6. What about the next one? Well, spoiler alert, they all find their right target. There's still one small flaw in this principle, and that is that I need to enter a whole package into each train describing where the train is supposed to go. And 2 trains with the same target will carry the same package. And actually, that is silly, isn't it? Why not store the information that leads to a specific track inside that track? Because that way I only need to store that list once in one place. And if I later want to change it, I change it only in one place and don't forget another. Right? It's just that the code becomes a wee bit more complicated. And that's why I wanted to begin with this method. But let's correct this now. I'll take the list which I have inside this train here, and I cut it out. Right, that puts it in my memory. Now I select the track number 7 and open its properties and paste whatever I deleted from the train. And I'll repeat that now for all the other trains. Now how about we give our destinations names? Call this Aberdeen and Basingstoke, Cardiff, Dorset, Edinburgh, Farnborough, and Greenwich. And that's what we store inside the train now. Every train now gets one variable with an object in it. And the object is our target, our destination. And inside the destination, I store my track. So if it's track number 1 I want to go to, I store Aberdeen. And to speed things up, again, I copy my variable. And that way I only need to mend the name. Yeah? Copy and paste. And give it the correct name. Find the next train. And give it the proper destination. I'm rushing through this now, because the principle should be clear. Alright, there you go. Now we need to change this a little bit. Before, we had the route stored in the vehicle. We don't anymore. Instead, the vehicle now contains a track, and the track contains the route. So the triggering vehicle has a destination, that's a track, and inside that track, inside the track that we found in vehicle destination, that's where we find the list called route. Quick check. That seems to go to the right place. So does this. Alright. Make up your mind time again. And now it's easy to change the train's destination, because all I need to do now is change that one object stored in the train. You know, give it the proper destination track as an object by whatever means, and all is set, because inside the track the train finds the path to the track. And that's how I would do it. Thanks for watching.